welcome to another A-Level Computer Science video with me, Mr Goff, from MrGoff.com. This video will focus on client-server databases. A client-server database is a database that can be accessed from its server by multiple clients simultaneously. To do this, it uses database management software, often abbreviated as DBMS. This runs on both the server and the clients. There are many advantages to client-server databases, such as the fact that the database can be accessed by multiple users simultaneously, the fact it can be accessed from several places, meaning firms with different branches can share a single database instead of each having to have their own copy, which would then need to be regularly updated as the data would go out of sync with each other. Access rights and security can be centrally managed, and backup can also be centrally managed. A key problem that can arise with allowing users concurrent access to a database is what's known as the lost update problem. This is where one client downloads a copy of a record from the server to their machine in order to edit it. While they are editing it, another client downloads a copy of the same record. Whichever of these users saves their data first will have it overwritten by the other. If we look at this example below, client 1 downloads a copy of a customer record in order to update the address. Meanwhile, somewhere else, perhaps in the sales department, client 2 downloads a copy of the same customer record in order to update the amount of their discount. They save the changes to the customer's discount rate, but then after they've done this, client 1 saves their record. Their record still has the old discount rate, so when they save the new address, they cancel out the discount rate that was entered by client 2. In order to prevent lost updates, records can be locked when requested by a client until the transaction is over. If another client requests the same record, they will be denied until the initial transaction is complete or abandoned. Record locking can lead to another problem known as deadlock. This is when two or more database transactions are waiting for each other to release record locks. If we look at this example, transaction 1 has read record A, causing it to become locked. It needs to use record B to complete the transaction, but record B is currently locked. This is because transaction 2 has read record B, causing it to become locked, and it is waiting for record A to become unlocked so it can complete its transaction. This is deadlock. A database needs to be able to recognize when record locking has occurred and apply serialization methods to deal with it, such as timestamp ordering and commitment ordering. Serialization is a way of ensuring no two transactions can overlap in time. A new transaction can't start until the old one is finished. It can be implemented using timestamp ordering or commitment ordering. With timestamp ordering, transactions are given a timestamp when they begin. If two transactions affect the same object in the database, then the one with the earlier timestamp should be applied first. Each object in a database also has a read and write timestamp. When a transaction starts, it reads an object and sets the read timestamp. When it goes to write to that object, it checks the read timestamp, and if it has changed since the transaction started, then it knows that the record is being accessed by another transaction and takes appropriate action. Commitment ordering is another method of serialization. As well as making use of the time transactions were initiated, it also considers how transactions depend on each other. The less important transactions, which many other transactions do not depend on, will have to wait for the more important ones. That brings us to the end of this video on client-server databases. Join me again soon when I'll be back with more A-Level computer science videos. Use the resources at MrGoff.com to help you revise computer science. And until next time, it's bye for now.